BOPIE, my wife, would like to see what a piece of Lutetium Aluminum Garnet, also called LuAG for short, would look like when cut into a gemstone. Now, LuAG is created for scientific purposes and it's used in lasers. With a hardness of 8.5 on the Mohs scale, it's also well suited for jewelry. Now, LuAG fluoresces and it's quite bright, brilliantly bright in sunlight. It's like a mini sun. It's also very dense, so it weighs more than many other gem materials. This piece weighs in at 83.6 carats, and since the gem is like a mini sun, I believe I found the perfect design for my rather large piece of LuAG. I got this LuAG from a vendor who specializes in lab-created material, and they're just up the road a piece up in Raleigh. And for those of you not familiar with this area, that's called the Research Triangle, and it covers the metropolitan area of Raleigh, Durham, and Chapel Hill in North Carolina. It's named for its proximity to three major universities: Duke University, North Carolina State University, and the University of North Carolina at Chapel Hill, and for being a hub for technology and biotech companies. This area also includes Research Triangle Park, which is the largest research park in North America, and is home to more than 300 companies and 65,000 employees. So my vendor has a fertile hunting ground for some truly unique lab-created gem material, like LuAG. As I said earlier, LuAG looks like a mini sun when it's cut and polished. It is so bright in the sunlight that it's incredible and very hard to photograph. You just have to see it to appreciate it. And since LuAG is like a mini sun, I found what I believe to be the perfect design to use on my LuAG. This design is called Salamando's Inferno, and it was created by Arya Akhavan. Now, I have cut many of Arya's designs before, and I always find them fascinating, and this design is no exception. What I like best about this design is the sun symbol that Arya put on the crown. Perfect for my LuAG. Okay, to mount my gemstone onto the dop, the first thing I do is get an oversized dop about the size of the gemstone, and that will help me center the stone in my dop because it'll fit just perfectly. So once I get it centered with using this dop, I'll swap the dop out and use the dop that I'm actually going to attach to the gemstone. Because the top and the bottom are probably not perfectly aligned, I use a piece of artist putty. You can use silly putty, crazy, anything will do. And one box for a couple dollars lasts a lifetime, so that's just going to help the bottom adjust as I push down on the top part to make sure it's level, to make sure the dop is level with the top. So then I put my oversized dop into my transfer fixture and align the stone so that it's just where I want it, so the stone's centered in the dop. Then I push it down with a lot of force to force the bottom part into the putty, and the top part is flat. So I double check, make sure it's where I want it. And then I simply remove the temporary dop that, again, all that was for is to help center the stone. And then I'm going to put the dop in again that I'm going to use to cut. And it would be very hard to center the stone if I just started with this dop, so that's why I use the oversized dop. So now I'm going to get my super glue ready and put it on the stone. So all I do is put my glue onto the dop, and I want it to run down the dop a little bit and go to the bottom side of the dop, like that. And then I'll push it down onto the stone, tighten it up, and then I'll put a little more super glue on the dop, making sure that all the way around there's glue touching the dop and the stone. And the good thing about this UV activated super glue is it doesn't harden until I hit it with my UV light, and then it hardens instantly and is ready to cut. So make sure I've got everything I wanted. I'll turn it over and make sure it's good and everywhere on the dop and the stone. And then I just hit it with my UV light. And the gemstone is very reactive to ultraviolet light. That's why it's changing color. In fact, you can't see the color very well with this camera, but it's a bright, bright lime green. When I hit it with UV light, it glows. So about 2 seconds is all it takes. I spend more than 2 seconds because I'm going to start cutting right away. Then you can touch it. It's not the UV. The super glue is rock hard. We're ready to cut our stone. Okay, so we just put our LuAG, Lutetium Aluminum Garnet, into our spindle of our machine. And since it's already kind of square, we just want to use it, the sides with the corresponding with the 96, 24, 72, and 48. And that way we'll have the least amount of loss of our LuAG. So now I'll use my 320 grit lap and preform it by cutting the pavilion to a center point. Okay, I've cut the first set of instructions, the P1 tier or row. I didn't cut quite to a center point, but I'll get there with the next lap. But what I want to do next is skip the rest, the P2. I want to go cut the G1 just to true up the square. And then I'll have a good idea of how big this stone can be. It should be around 14 millimeters, but let me true up the sides, and then I'll go back with my 600 grit lap. Okay, when I measured the width, which is, it's a square, so either it's going to measure both of these sides the same. It's about, it's going to end up being about 13.5. So then the question is, do I have enough space to cut the upper half, or do I have to make the stone smaller? So the way you determine if you have enough space to cut the rest of the gemstone, what will be the upper half, or the upper half right here, is you measure your width, 13.5, and you multiply that by the C to W ratio, which is given you in the instructions when you use GemCut Studio or GemCAD. And in this case, the C to W ratio is 0.289. So that 13.5 times 0.289 gives you 3.9. And then you want to add space for a girdle. So you need 3.9 millimeters from here plus the girdle. So measure if I've got it. And I have well over probably 5 millimeters. So 5¼ millimeters. So I've got plenty of space, plenty of room to cut the upper half of the gemstone, so I don't need to make it any smaller. So we should end up with a gemstone in the neighborhood of 13 millimeters width. So now I'll go back and continue to cut our gemstone, and I'll switch to my 600 grit topper for the next step. Okay, so this design is a little more complex than it looks. So I'm going cutting now with the 3000 grit diamond on a bat lap, and things were not quite aligned the way I needed them to be. My P4 wasn't going all the way up to meet the culet. So for the pre-polish with the 3000 grit diamond on the bat lap. I'm focusing first cuts are the P3 and the P4 so that everything matches the culet. Then I'll use I'll go to the P1 cut and move, that's these two, and move them in so that my P3 just reaches a point. Then I'll go walk the P2 facets up so there's a nice straight line between the P1 and P2. And I suspect I'll have to adjust the outer girdle finally, the outer girdle facets, that's the G2, to get everything lined up after that. But that's fine because adjusting the G2 girdle does not affect the length and the width of the stone, so that won't affect the size. It's the G1, these facets, that affects the length and the width. So I think that'll put me back in alignment and have all my meet points meeting again, so I think that's how I'm going to proceed. Okay, I've got one facet left to cut, one row, one tier, the P2 facets. That's these right here. I need to bring those up so that this line goes right up to there so that there's a line all the way up. So the P3, P4 facets made a point here. Then I brought the P1 in and made a point here. So that's, again, that just leaves the P2. I think when I get done with that, I may have to go back and cut the G2, the girdle. I may have to cut that depending on how much moving this up here affects the girdle. But again, that won't affect the length and the width because that's controlled by these two girdle facets here, the G1. So it's coming along nicely. It's a little complicated, I think, of a design for a new cutter. And the reason is that you lose when you make your center point with your initial cuts, you lose that center point as you cut in the rest of the pavilion facets. So it's easy to get off a little bit, but I think we're back on track now. Okay, with my 3000 grit diamond on a bat lap, I was able to tighten up all the facets, all the meet points by tightening up the P3 and then using the P4 to make a meet point at the culet, and then the P1 to make a meet point at the girdle of the P3, and then the P2 to straighten up that line between the P4 and the P1. And then I did have to adjust the G2 girdle to bring it in so that everything lined up. But everything works out. Now it's just where I need it. So now I'm going to polish it. I've been told that 60,000 grit diamond works great, bat lap, but I think I'm going to try the 60,000 grit diamond on my zinc lap, just because I grabbed the zinc lap first. I'll give that a try and see how this polishes up. Okay, our gemstone polished right up with 60,000 grit diamond on a zinc lap, and I think I could have probably used a bat lap or a copper lap, or I could have used aluminum oxide on a tin lap. I believe all those would have polished up this material, but I just tried the zinc lap and that worked great. So I will now transfer the gemstone so we can cut the upper half. Okay, I've gone over the first three facets on the crown with my 3000 grit diamond on a bat lap, and the previous facets I used 12M, which is about a 1500 grit lap. So you can see the difference between a 12N, which is kind of a matte finish here, and the 3000 grit diamond on a bat lap. Looks almost polished with 3000 grit. So I'll continue to work on this with the 3000 grit diamond on bat lap for pre-polish, and then I'll go to polish. So this is pre-polished with the 3000 grit diamond on bat lap. It's glowing and sparkling quite a bit just with the pre-polish. So now I'm going to go over this stone and polish it, and I'll use aluminum oxide on a tin lap. It should polish right up because I have a very good pre-polish. Okay, so I finished polishing up the upper half of our LuAG, and used for the upper half of this stone, I used cerium or aluminum oxide and a tin lap, and it polished right up. So just like garnet, aluminum oxide works well. So the bottom half was 60K diamond on the bat lap, and the top half has been aluminum oxide and tin lap. So I'm going to cut the table now, and I'll probably just use the aluminum oxide for that with tin lap because I've already got that lap out. Okay, I finished polishing the table with aluminum oxide and a tin lap. It polished right up. So the upper half of this stone I used aluminum oxide and a tin lap. And I misspoke earlier when I said for the bottom half or the pavilion of the stone that I had used 60,000 grit diamond on a bat lap. No, I used a 60,000 grit diamond on a zinc lap, although I'm quite confident that the bat lap would have worked great. But I used a zinc lap this time. So I've tried two different polishing methods on this stone, oxide and diamond. They both work great. So now I'll take the stone out of the, take the DOP off of our machine and soak it in acetone to remove the stone from the DOP. Then we'll weigh it, measure it, and send it off to BOPIE. Today I cut a rather large piece of Lutetium Aluminum Garnet, or LuAG for short. This lab-created material is used for laser rods and other scientific purposes. Now, I normally don't care to cut lab-created material as a rule, other than lab-created ruby, sapphire, or emerald. But in this case, I made an exception because LuAG is so unique. It positively glows in the sunlight, making it a very unique gemstone, which I just had to cut for myself to experience. I didn't have any issues cutting or polishing this material, as it cuts and polishes just like any other garnet. And I polished half with 60K diamond on a zinc lap, and I polished half with aluminum oxide on a tin lap, just to try out two techniques. They both worked fine. I suspect a bat lap would have also polished this material right up. The final gemstone is bright, like the sun, and this design has the sun motif on the crown, which to me makes this design perfect for LuAG. I would not recommend this design for a brand new cutter, as the pavilion is a bit tricky and takes some experience to ensure all the meet points meet. However, any cutter that has cut a handful of gemstones already should be able to tackle this design with no problems. The design is awesome, and I wouldn't recommend you give it a try. Again, that sun motif on the crown really makes the design. Drop me a line on Facebook if you do try this design, and let me know how it worked out for you. And as always, happy fasting, everyone.